All right, so our topic of discussion today is Unit 2.5, and this is day 1, and we're going to be talking about inverse functions. And we're just going to be looking at what different types of functions that we can use and talk about different variations of what we can have and what things will look like. So the first thing is that we're going to identify inverse variations and apply these to solve real-world problems. So the first thing is going to be a day 1 and a day 2 video. This one we're just going to get familiar with the two different types of relationships that we can have and what they look like and how to create the equations from a table of values and things like that. So I have two different types of variations in functions. The first one is what we call a direct variation, and this is something that we've probably been using a lot of. If you look at this, we have y equals k times x. What this is x and y are still ordered pairs that we're typically used to, but k is what we call a constant of variation. And what this tells us is this constant of variation is just this value at which things change. And so we can see that the relationship between this here is that I tell you an x value, you multiply it by k, and then you get a y value. And you do that again, and you do that again. And we're going to look at what that is. Now if we look at an inverse variation, now an inverse variation is very similar to a direct variation, but instead we have a fraction and x is in the denominator. And so k is still the same thing. This is still a constant of variation. And that's what we're going to kind of be focusing on. We're not necessarily worried about what x and y are. What we're really concerned about is how that they're changing and what the relationship of them is. And that relationship is kind of based on whatever k is. That's kind of our deciding factor of how this function and how these things are going to be changing. All right, so if we kind of look at a general template for what direct variation looks like, the first thing that we have for our direct variation is going to be our equation, which is y equals kx. Now, we're very familiar with y equals kx before, and we'll take a look at this. And so, first of all, when we look at a typical direct variation, we can kind of describe this as what we would consider a direct proportionality. And so if y, the typical description of this is if y varies directly with x. So if you ever see, kind of like how we would look at other things, but this is typically as y varies directly with x, or kind of y depends on x. And so we're just talking about the relationship between these. Now more specifically, what this will look like as x increases, since this is a direct relationship or a direct variation, y will also increase. And so what we would see is that as we increase our x values, so if we start at 0 and we go from 1 to 2 to 3 to 4, we will also see those y values increase along with it. And in a similar fashion, as x decreases, then y will also decrease. And so the reason that this is a direct variation, if you look at this, as my values of x go up, my y values will also go up, and as my x values go down in my list, my y values will also go down with this. Now what this does is this belongs to the linear function family, and if you really look at this, this value of k, this constant of variation, acts as kind of like our slope. So this tells us how much that it goes up by every single time, or how much it goes down by every single time. So this graph is a straight line, so anytime that we look at a direct variation, our graph is going to be a straight line just because of the relationship between those. So if we use this example of y equals 3x, if I plug in -2, I'm going to get -6. Now because this is a direct variation, when I go to 0, that means my x values are increasing, so from -2 to 0 that increases, and then all of a sudden my value is 0. Now obviously we can see that from -6 to 0 that also increases, and so we can kind of keep going in that fashion, and then we get 9, so the values of x are increasing from -2 to 0 to 3, and so my y values will do the same thing. So a direct variation, kind of the biggest thing that we're going to get from this is that as x increases, y increases, and as x decreases, y is also going to decrease. Now on the other hand, we have this indirect variation, in which we call an inverse proportion, and so the same kind of thing happens. Y would vary indirectly with x. Now my equation for that one is y equals k divided by x. And so we can kind of look at some type of relationship that would happen. Now with an inverse relationship, if you think about the inverse of what we were doing before, as x increases, what's going to happen this time is that y is going to decrease. And so instead of having a direct proportion in which both of the x and y are doing the same thing, where they're increasing and increasing, we're going to have this indirect variation in which as one increases, the other one decreases. And so as x decreases, that would mean that our y values will increase. Now we could see that very easily with particular tables or particular graphs. So as we look at this graph here, and we can kind of see an example of this indirect variation, that as I increase my x values and I go to the right, my values of y start to go down. So if we look at miles per hour, as time goes on, my speed gets slower and slower and slower. Now if I was to go to the opposite way of that, as I was to decrease my x values and start going backwards, I would see that my values of y would start to go up. And so I can start filling in this table at least to show this variation. So at 2 it's 120, at 3 it's 80, at 4 it's 60, and then at 5 it's 48. So as I increase my time, as I go down my table, I go from 2 to 3 to 4 to 5, my values start to decrease. Now if I was to go back the other way, which you can definitely go back the other way, you can see that my values would start to go up as my x values start to go down. So this is just the idea of an indirect versus direct variation. We have to remember our two equations. That's kind of the big thing that we're looking at, as well as what's actually happening. So as x increases, what does y do? As x decreases, what does y do? And that will tell us whether we have a direct variation or an indirect variation. And so what we can do is we can look at what we have going on as far as identifying a relationship. So we either have a direct variation, which is y equals kx, or we have an inverse variation, that is y equals k divided by x. Now, we kind of already looked at, with our direct variation, as x increases, y will increase. As x decreases, y will also decrease. With our inverse variation, as x increases, y will decrease. And as x decreases, y will increase. And so what we're going to do is we're going to identify this relationship to see if we can see whether it is a direct variation or an indirect variation. Now in some cases it could be neither one of them, and that's okay because we can't just necessarily limit everything into these two scenarios. So let's take a look as we go from one x value to the next x value to the next x value. We can see that these values are increasing, and as we go from one value to the next value, we have values of y that are also increasing. So as far as we can tell, as of right now, this is what we would consider a direct variation. Now what we're going to look at specifically is we want to look at specifically if these values are doing the same thing every time. So we also want to make sure that we check the scale. We want to check to make sure that as it's increasing by the same amount every single time, rather than, the changing each and every time. But as we can look at right now, this is simply what we would consider a direct variation, because as x increases, y increases. Okay, so let's take a look at another type of relationship. So now that our table is arranged a little bit differently, but that's okay. So let's identify our x values as we move from one direction to the other. So as I go from here to here, and from here to here, I can see that my x values are decreasing. And from here to here, I'm going up, and then from here to here, I'm also going up. So my values here are increasing. And so what I can look at here is I can look at the fact that because x is decreasing, that y is increasing, and so this is going to be an inverse relationship, because we said that with an inverse relationship, as one increases, the other one should decrease, and vice versa. But with a direct variation, they're both going to be doing the same thing. As one decreases, the other one decreases. As one increases, the other one will also increase. But in this situation, we have a decreasing and we have an increasing. And so we can identify this as being an inverse variation. So the whole idea of identifying the relationship is, are they doing the same thing or are they doing different things? Is one increasing and one decreasing, or are they both increasing, or are they both decreasing? So that's kind of what we're looking at as far as identifying the relationship. Now, the second part of this is not only identifying the relationship. So if we look at step 1 here, if we were to create the equation for our variation, either direct variation or inverse variation, our first step is to identify what we think that particular relationship is. Now, we don't always necessarily have to keep it that way. So just because we think that it's a direct variation or an inverse variation doesn't mean that it's going to be that. And so what we need to do is we need to identify the relationship. Now this is the example that we had before, and so we looked at this and we can kind of look at it again. These values are increasing, these values are also increasing, and so we can look at this as being what we think is a direct variation. Now, in order for us to identify if this truly is a direct variation, we're going to need to write the equation. So y equals kx. Now, each one of these ordered pairs needs to follow this particular rule in order to be able to identify itself as a direct variation. And so the second thing is we wrote the equation. Now what we're going to do is we're going to substitute each. So I'm going to write over here, each x and y pair. And by doing that, we're going to solve for k. Now the problem with this is we want to make sure that that k is a constant of variation, meaning that it has to be the same for every single pair that we're given in our table. So we're going to need to do this, in this case, 3 times over. So what I'm going to do is I'm going to solve for k in each one of these situations, and so I'm going to set up my x and y pairs. So my first pair is 18 equals k times 1.2. And so by doing this, what I'm going to do is I'm going to solve for k, and if you notice, we can solve for k very easily by dividing 18 by 1.2. And when I do that, I get a k value of 15. And now I need to keep doing that because I want to make sure that that k is the same every single time. So I'm going to go to my next equation, substitute my x and y pair. 21, does that equal k times 1.4? So again, I'm going to divide those two together, and I get a k value also of 15. And so the reason that I'm doing this, the reason that I'm setting it up into this equation, is because I want to make sure that that k is actually a constant value. So we notice here that k is 15 in both instances. And so the reason that I'm doing this, I'm finding k, is because I want to make sure that it's the same every time. Alright, so I have one more to do here, and so I have 24, which is y, should be equal to k times 1.6, and if I multiply those, or I divide those, we also get k is equal to 15. And so from what I can tell, this is a constant of variation, and so what I've basically done is I've solved for k. Now that I've solved for k and I've realized that it's the same every time, this is actually a direct variation. But now what I need to do is I need to substitute into my equation model so that I could represent this for any function that I have. So if you give me an x value, I should be able to tell you the y value that goes with it. So I'm going to take this 15 and just simply substitute it into my equation. And so my equation for this direct relationship is y equals 15x. And so part of identifying a relationship is also writing the equation that goes with it. So we just have to make sure that every time that we're given a table of values that we're finding the k for each particular ordered pair so that we can find the respective k value and make sure that it's the same every time. Okay, so I'm going to do that with this one too as well. And so first of all, I'm going to identify my relationship. So as I look at my x values are decreasing as my y values are increasing. And so from what I can tell right now, this is an inverse function. And so my inverse function, my second step is to write the equation, is y equals k divided by x. Now what I need to do is I'm going to do step 3 and 4, and I'm going to substitute my x and y pairs and solve for k. So I'm going to take a pair. So I'm going to start with 0.8 and 0.9. So y equals, so 0.9 equals k divided by 0.8. In order to solve this one, I would just multiply these two values together because this is in the denominator. If you think about solving a one-step equation, since I'm dividing, I need to multiply on both sides. So multiply by 0.8. And so that gives me a k value of 0.72. All right, so there's my first value. Now I need to compare these to the rest of these. So 1.2 equals k over 0.6. And I can multiply those two things together. And I get a k value of 0.72, so this is looking good. And then my last one is 1.8 equals k divided by 0.4. And so if I type those in, I also get k equals 0.72. So now that I've identified that my k value is the same every time, now I can write my model equation. So again, we're using the fact here that we have this inverse relationship of y equals kx, and I know what my k value is. My k value is this 0.72 because it's been the same every time. So I just plug that k value into my equation. So my model equation is y equals 0.72 divided by x. And so this is pretty simple, pretty straightforward as far as finding the relationship because you're just looking for it. But really the difficult part is identifying what the equation is and then solving for k. And so we can either solve for k by either multiplying or dividing depending on what the situation calls for. And so that's just simply how we identify inverse or direct relationships and then find the equation. Now the last part of it is just identifying the direct variation versus the inverse variation. So first of all, remember your equations, y equals kx and y equals k divided by x. The k is the same thing. K is a constant of variation. In order for this to be a true direct variation or a true inverse variation, this needs to be the same each time. So no matter what kind of table that you're given, no matter what kind of information that you're given, if that k is not the same, it's not direct or it's not inverse. So we're always kind of looking at it hypothetically. So in certain situations, if it's not what we think it is, because the k isn't the same, then we can't use it as being direct or inverse, and we'll talk a little bit more about that in class too as well. So remember your two equations, remember what k is and how direct variation and inverse variations work as far as their x and y values. And so that's going to do it for this video.